Well, let me remind you of what we were doing before. This was called divisor D. Let me just write it, divisor. Good? And this one was called a dividend, but I'm just going to use P as a polynomial. And this part was called a quotient, so I'm going to represent with a Q. And that was the remainder R, right? Can somebody describe the relationship between the degree, the divisor D, and the remainder R? That's right. You stop this algorithm whenever you see the degree of the remainder there. Degree of this part, renewed dividend has a smaller degree than the divisor here. Is that the case? X minus 3 has degree what? 1, and this one, constant term, has degree 0. So that's where you stop this algorithm, and you put it into a following standard form. So I'm going to write down the standard form. P, that original dividend, is, how is it written down? Divisor times quotient plus the remainder, right? This is the ultimate statement. All quotient form and everything is derived. And we're doing this long division algorithm to get this decomposition, dq plus r, right? So let me explain how you actually explain from this long division algorithm to get this statement there, right? This is a little bit of a theory. So I'm going to label that 2x squared here is a q1. Able to see that? q1. That's the first term in the divisor, the quotient. And the second term is a negative x. I'm going to label that with a q2. Is that all right? And the last term, which is negative 3, I'm going to label that with a q3. Okay? So I'm going to explain each step in the long division and translate into an algebraic expression. First thing we do is that here's a dividend that was appearing here. The next thing we do is that we make this choice, 2x squared, however that the choice was. Next thing we do is we multiply divisor to that 2x squared, which was q1. Is that right? That's what we do. We multiply that d, that's two terms, xn minus 3. We multiply that to 2x squared, and you wrote them down here. Is that right? So that's what dq1 is. That's what dq1 here is. Agree? Then what do we do with this dq1? You subtract that from the earlier line, which was dividend p. So I subtracted it here. Is that right? Okay. So that's, the p was up there and dq1 was down there. We subtracted it. And that's the result down there, right? So that's going to be p minus d times q1. Agree? All right, so we get this new dividend. You have to subtract it off. We look at this term, and we come up with this q2, right? So next thing you do is that you multiply d to q2 and write them down here. Okay, so I'm going to write down, this is d times q2. Is that right? Here's the divisor. Here's the second term appeared in the quotient. You multiply that and wrote down underneath that. Good? So that's your d times q2. That appeared right there. So you subtract that from the earlier line, which was this two term in here. You subtract it from that like this. Good? I'm going to put some parentheses there. This was this line right there. And you're subtracting dq2 from that second dividend. So that's this expression right there. Is that all right? Yeah. Then that's the result right there. Negative 3x plus 5 will be this entire three things, all written in this algebraic term. The next thing is that you multiply third term in the quotient to the divisor, which is d times q3. Is that right? And that's your d times q3 underneath it. And you subtract that from the third dividend there, which is the entire thing that's preceding. You subtract it again. All right? And what happened after you subtract it? You end up at this remainder r there. So this is the summary of the long division in algebraic expression. Okay? So we are about to turn this one into the standard form right there. So since these are all common, so here I'm going to call d factored out. And after you factor out d's, and you're left with this Q1 plus Q2 plus Q3 and equals R, right? Can somebody come up with a better name? You know, if you go back to where Q1 and Q2, Q3 are, that was up there in the quotient line, right? What is the sum of Q1 plus Q2 plus Q3? That's better known as just a Q, right? So this whole thing is now, this is divisor P minus D times Q equals R, and if you add both sides dq, then you get the polynomial is D times Q plus R, and that's our standard form. Okay? So that long division is organized that way so that you can strip off one leading term at a time to get to this nice statement with excellent condition between this degree of the divisor and degree of the remainder. All right? So having lower degree in the remainder part turns out is a great advantage in this calculation. This is the kind of general explanation of why the long division gives you this nice statement there. Although it's just an example, I think it represents, in general, the complete idea about long division. Good? So let me write down